What if our dear sun turned into a black hole? What is our fate? And what will we see come the next morning? If there is to be a morning, of course. And will a black hole swallow the Earth? The beginning of a black hole is the most mysterious object in space, and they are areas of immense gravity. And though scientists call them holes, they aren't empty as we might think of holes. On the contrary, black holes contain very compressed and dense matter, a very strong attraction, to the extent that even light itself cannot escape from them, meaning they do not emit any light. This makes it impossible for us to directly observe them using telescopes. We're completely sure of their existence because of the weird behavior that materials exhibit around these holes. For instance, gases orbit around the black hole at an immense speed, close to the speed of light, emitting very high energy radiation. This indicates the presence of a massive gravitational source near these gases. Black holes come in a variety of sizes depending on the amount of matter they contain. Some may wonder about the origin of black holes. Some of them are formed as a result of the death of massive stars. When these stars consume all their nuclear fuel, their outer parts explode, forming what is known as a supernova. However, what remains collapses on itself under the influence of its gravity, becoming extremely dense. A black hole problem. You can rest assured, because our sun is far too small to ever form a black hole. They simply don't have enough mass to generate the gravitational force needed to become a black hole. For a star to become a black hole after its demise, it must be at least 10 times larger than our sun. But remember, any body subjected to enough pressure to become as dense as required can turn into a black hole. Imagine if the Earth was compressed to the size of a marble, and then it would become a black hole. And even a human, if we squeezed them to become smaller, in a billion,
better.
a grain of salt then becomes a black hole. Returning to our question, and our sun, assuming it somehow turned into a black hole and was compressed so that it became
It's
barren,
not easy to count 6 while eating.
that won't change its relationship with our planet or any other planets in the solar system, because their mass will not increase and because they will not approach any of the planets. So if our sun turned into a black hole, it wouldn't swallow our planet, but on that day we would witness the sunrise of a sun. It's the darkest and most bleak in our lives. Scientists in recent years have discovered many galaxies that contain massive black holes at their centers. Her word here is much larger than you can imagine, as these beasts have a mass about 100 million times that of the sun. Astronomers are still struggling to understand black holes and how they form in order to study the gravitational waves they create. Some believe these voids in the fabric of space formed in the first seconds of the universe's birth. But all we are certain of is their enigmatic nature despite being alike.
What if the only star in our solar system turned into cold debris?
What if our sun turned into a black dwarf? How long would Earth exist without light and heat?
The external ones who give their wealth to the sun, and how the dimming of the sun will change the universe. Every star has an expiration date, but that doesn't mean they vanish into nothingness. Stars like our sun don't have enough mass to turn into neutron stars, but eventually they end up stretching into red giants, their outer layers blistering away until nothing remains except for its core. At that point, the sun becomes a white dwarf, and the white dwarf's accretion disk doesn't undergo fusion reactions. It powers it. It gradually cools down to eventually become a black dwarf. And what we're going to say, there are no black dwarfs anywhere in the universe, as black dwarfs have not yet formed. As you see, white dwarfs may not produce any energy, but they have what's left of the needed energy to make them glow dimly. For several 100 million years, considering the universe is only 13.8 billion years old, we find that even the oldest white dwarfs still glow at temperatures. It's a few thousand kilometers, and in the case of our sun, the process will take an estimated quadrillion years to decrease its temperature and become a black dwarf. This time period is estimated to be a billion years from now, give or take a few million years. Do you think humanity will last all this time? Well, let's assume so. And what if our sun went out tomorrow? Hope you have enough batteries, because the entire solar system will be plunged into utter darkness. And put on some coats, as it will be much colder too. Talking about planets, we're a bit spoiled here on Earth with our sun. With all this light and heat provided by the sun, we're able to build and furnish comfortable homes aboard rockets launching into space, and it's easy to forget that we're just a tiny dot in the universe. But if our sun stopped burning, it would become immediately clear. We would just be floating in space. After the first week without the sun's heat, Earth's surface temperature will drop to 0 Celsius, which is 32 degrees Fahrenheit, and will decrease even more year after year. 100 degrees Celsius below zero. If the sun turned into a dreaming black dwarf, which is highly unlikely even in our hypothetical scenarios. In fact, for the sun to become a black dwarf, it must go through all the stages of stellar life. From the position of the sun in the main sequence where it is now, the sun will expand into a red giant, then fade into a white dwarf state, and only then will its temperature begin to decrease, turning into a black dwarf. And in the red giant phase, this sun will cook our Earth, and it's likely that it will swallow them all up into solid Mercury and Venus at this time. We don't have to worry about freezing to death when the sun shrinks into a black dwarf. What about the other planets? Those lucky enough to avoid the scorching flares of the red giant. Well, these planets would continue orbiting around the remains of the sun as if nothing happened. Even though the sun will shrink to the size of Earth, its mass will remain the same, meaning its gravitational pull won't change. On the grand scale of the universe, the death of our sun won't change anything at all. The sun won't be worshipped as just another star fading away. It's very small and insignificant. Even then, it won't darken the universe any further. But what if all stars died at the same time? Well, that's another story.